When we took the old Flyback out, we just snipped the leads on this socket. This is the socket for the high voltage rectifier tube. And now that we have our nifty new Flyback, we're gonna solder these on, and we've come this far. We're gonna replace the second anode lead with a brand new one, or a brand new old one. You know, I buy these things when I see them for sale on eBay or whatever, and I put them in a box and I never use them. So this project is deserves a brand new, because there's nothing wrong with this. This is the old one. Nothing wrong with it, but we're gonna not use it. We're gonna use a new one. And the wire's a little bit longer, a few inches, 5 inches. So maybe that helps us, maybe it doesn't. I don't know, but we're gonna find out. So this project's gonna, well, this wire is getting, this is 40,000 volt wire, and it's pretty stiff. And the wire's gotta come around here. And then this, well, like that, this fiber ring goes around it as a retainer. And the wires get retained and they come in through the front. And then it gets screwed into the plastic receiver in the high voltage box. These are 2 strands of the stiffest wire I've ever touched in my life. Oh, did this break? It sure did. Look at this. Wah, wah. Okay, now what? Now what do we do? And that's fine. That's as good as it was before. So this wire is incredibly stiff, and I'm not sure of the benefits of trying to soften the wire with a heat gun. Well, there we are. It looks like it's going to fit just fine. The nubby thing isn't too big. So we're good. We're good to go on this. Well, I fashioned up a little holder thing using the 2 screws on the bottom of the chassis. As you can imagine, all of the weight here is here at the transformer, but it gives us a very stable platform now, but it also gives us easy access to the high voltage cage, but also access to the wires underneath. So we don't have the bulk of the cabinet around it. We just have access to where we want to go. So we're gonna take advantage of what we can do here with this little wooden base, and we're gonna put it on the workbench so we have a nice comfortable working situation. Well, I got some new parts in, and that was fast. I got them from this eBay seller, a gentleman named Ben at Affinity for Artifacts. And he's got a lot of these sort of oddball things now. These are 2-watt resistors. These are 68K, but these bad boys, those are 22 megs at 2 watts. Carbon comp, made by Alan Bradley. And then he's got a pretty darn good selection of axial lead capacitors too. So highly recommend it. His service is always fast. You order it and it's usually in the mail the next day. So, well, these two 22 megers are going to the old Flyback, the rebuild of the old Flyback, which will probably complete and then never use the Flyback. But the 68K is specifically here to replace this one. I still don't really understand why a couple of these Flyback assemblies have these 27Ks on them. And unless the windings are different, or just the expectation of whatever voltage is at this point, because this is one of the boost outputs. Actually, this is the this white wire goes to the damper, and that is the source for the 1280 volt boost. So we're going to replace that one with this. It's a higher value, so if we are changing something because the windings are different in the transformer, then we're not going to hurt anything by putting a higher voltage, a higher resistance value in there. So we'll just keep an eye on it. But at that point, when the set's running, there should be 1280 volts. And also at this point here, the gray wire, that is the other boost point where we should see something like 870 volts there. And then this goes up into the, this is the focus control. That's the focus resistor. We attach the black lead from our CRT socket to this juncture right there. Both of these points where they're soldered into are just tie points. So they do not have connections to the transformer underneath, which makes this a much simpler task. I would get pretty concerned about unsoldering, well, this point here. This has a transformer lead, as does this right there, as does this point here. So I wouldn't really want to mess with something like this, trying to unsolder those and run the risk of breaking one of those little wires. Using our soldering iron as a pry bar. We have got that free. We are scot-free here. This is warm. And I thought that I would just kind of get it in here, drop it in place, do a little bit of pinchage and solder that side, and just tack a little bit of solder on down at the bottom of that pin there, right there, because this particular loop of wire, not a loop of wire, that little tie point there, is our super boost. That's the 1280 volt boost place. And the wire that had been soldered on by Thordarson, first of all, it wasn't going to be long enough to reach into the chassis. And then as I tried to strip the wire back, I tried to use one of these giant mega wire stripper things where you can just put it in and do that whole one of those type of strippers, and all it did was damage the wire. I guess I didn't realize at this point, would have made sense if I had just thought about it, but the wire that was in there is double insulated. So the outer jacket is a color, in this case it was sort of a purple, and then the inner jacket is white, and these two things are probably made together, dipped together or something. So I can't get this back in, and this wire is too short, and so I've got to come up with something else. There's the wire that is attached to the chassis still, because we snipped that lead last time on the old transformer, and maybe it'll be long enough, and if it is, and I can strip back just enough, I can solder it on that point. But that also is a double insulated wire once I started looking at it, because it's, like I said, there's 1280 volts of voltage there. So your typical wire, these, say as an example, I think these are 600 volts. This is a 600 volt wire. So can't just use anything as the short version. This stuff is this silicone insulated wire. Comes all the way from Amazon, and it's copper stranded, 18 gauge, super flexible, but it's only rated for 600 volts. So it's really hard to find wire that is either not 30,000 volts or 600 volts. So I wonder if this kind of stuff was specially made, but it's very inflexible. It's really rigid. Pinch this a little bit. Yeah, nice tight mechanical connection, and then we'll just tack some on, because when we solder that wire from the chassis, we're gonna end up with, we're obviously going to end up with some more solder at this point. Caution, heat damage will occur to your thumb. Alright. There we go. Oh, hot. Okay. Alright. 668K. 68,000 ohms. All right, 68,000 ohms. Still hot. And this is our boost point, our high boost. This is our low boost point. Actually, the boost is generated here in the flyback, and it goes. This gray wire takes it back into the chassis, and otherwise the boost travels up to these 22 meg ohm resistors, goes to the focus pot. The other side of the resistive element goes to this point, and it becomes ground. Everything travels through the capacitor to ground right there. And then at the wiper of the focus pot is the 4.7 meg resistor that takes it from this point to the CRT focus pin. A new old stock flyback, specially modified. So we're going to use these wires that are come from the manufacturer. They're soldered to the secondary of this flyback assembly. So the core of it goes like this, of the transformer. So this is truly the secondary of the transformer, and I believe these 4 wires go to the convergence circuitry. Black is the ground for sure, so there's 3 wires that go into the convergence network. And this white wire goes to the damper, and this gray wire comes off, actually comes off of our boost source. So this is our 870 volt boost right there, because there's a transformer lead right underneath this. You can see the wire right there on top. So the boost comes from the transformer at that point. And the boost being a sum of the B plus and the extra energy generated by some of the windings. So it comes off the boost point here, and then it goes down into the chassis. And then this point we were looking at where there's no wire soldered. Yeah, so these are the connection points from the Molex connector, let's just call it that. And I find that this is helpful. Just take pictures, and sometimes you just gotta use the ink and print it out, because this is a really handy reference. So point 3 on here, right there, that's where the orange wire comes off of the Molex connector, which is pin 2. And pin 3, the blue wire, comes off and goes to the boost connection. And the boost connection is right here. That's our gray wire that goes into the chassis, but it also gets a connection to that connector. And there just isn't a good way to really do it. But that's the way this has been conceived. It's going to be a delicate and kind of messy connection to get that there. I hope that wire, I hope this blue wire, this blue wire is long enough. I mean, I really don't like the idea of splicing ½ an inch of wire on something. But we won't know till we get it in there. So this point here, this connection point 2, which goes to the boost rectifier. Underneath, I can feel a wire that comes from the transformer and it connects here. So you can see the thin wire there comes from the transformer, connects to that point, and then the 1280 volt boost comes through here. So nothing gets connected to it at this point. This is the orange, the orange wire. And then the blue wire off the Molex connector goes to that point. I'm not sure how we're going to do that. Yeah, so anyway. And then pin 1 on this connector, believe it or not, joins together with this yellow with a black stripe wire to this point here. Now, this is kind of an interesting thing. This striped wire goes on the back of the chassis. It kind of, I don't know why there's blue paint on this wire, but that's it. That's the wire. And it goes to this point here on this phenolic strip. And on the other end of this phenolic strip is this receiving end of this jumper. And this jumper, in that position where we are connected to that yellow and black wire, is a width increase. And if we connect this to this point, that is no width increase. So this, I suppose, sends boost voltage out there, or takes boost voltage in from what would be the wiper of the position pot wiper. So on this particular one, it's just kind of odd to me, but that tab right there is the wiper of this potentiometer, and I've checked it with an ohm meter. So it's a bizarre thing how to connect to that. We're gonna find out when we get there, but that's where that goes. So before we pull these wires back through here, and my intent was to, I marked the colors here and down here. I was going to pull this bundle back so we have access to getting the new flyback in here. And but first I was going to change this capacitor. We were pretty bold with our decision to put in some new old stock cans, and I think they worked fine. The old ones were getting hot, and these are cool. So that's awesome. But and I have no reason to suspect that this capacitor is not a-okay. But our goal is to figure out why this resistor keeps burning up. So they are related. So one side of this resistor goes to this tab of the multi-section capacitor. Then it goes to the tab of the positive side of that capacitor, and then from the positive side of that capacitor, that red wire goes down to the I guess the primary of the vertical output transformer, and then from that point the blue wire goes to B+. So we're just going to eliminate this from the question. I do have an old stock version of this, but let's not fool around anymore. I just got this from our friend at Affinity for Artifacts. It's a 400 at 450. I got some plastic tubing that I cut to wrap around this capacitor, and it drops right into that clip that holds that one. So this is the negative side of this capacitor. It goes across down here, and it ends up at this point here, which is one side of the screen resistor on the horizontal output tube. When we first looked at the chassis, this resistor was baked, burned up black. So this has had some problems, this circuit loop. And this one was just also black. It's just baked. And this one, though, continues to burn up. So we're trying to get to the bottom of this. And this capacitor is essentially that joins the two together. So at this point, if we still have problems with these resistors burning up, it'll be pretty evident right away if the vertical output transformer is arcing inside and you really can't test it. You just have to determine that while it's working and under load. And yeah, this is pretty old, and I don't know how to interpret. You can't really tell from the way it looks, but these are prone, or had been prone, to fail. And I do have a replacement for it if we have to. So I think we're good to go. We're going to work on getting the... We're going to replace this. I'm kind of surprised that this didn't shatter. Well, it already is broken, but usually the solder comes right off the disc. So anyway, that's what a thermistor looks like. And that's what the wires look like. Now, it's interesting to note here, clearly there's been a lot of heat in the chassis at this point. This phenolic is darkened. And there's other parts of this chassis where there's phenolic that's darkened due to heat. Those are all valuable clues when we're trying to figure stuff out. And up here, of course, the phenolic near this resistor that's been burning up is darkened. And where else did I see some other areas? Maybe up here in this width control area, high voltage area. These are screwdriver adjustment controls up here. And this is the horizontal oscillator control, which is the horizontal hold control. And this is also a screwdriver adjust control. So there's like vertical linearity, vertical height, vertical size. But some of these are used controls. This is vertical hold, brightness, contrast, peak picture, which is essentially sharpness. And this is tone, and this is like AGC. So the ones that are going to be used, we're going to squirt, and then these are the G2 controls on the back. Those are going to get squirted, and the screen controls, squirtage. So start with this one. Gonna give it a spritz, and then I'll work them in. So just the ones that are gonna be, because essentially what I don't want to do is disrupt the settings of the vertical linearity, vertical size, vertical positioning. Not going to touch the horizontal hold control. So we want to keep the stuff that, but these are the user controls. So, you know, this is easy enough to figure out. This is the vertical hold, and we still are not sure of our vertical circuits to be determined. But brightness and contrast, these are controls that were used a lot when the set was being used in its day, and probably pretty worn. You know, these are would be the controls that we may have to replace. So, but we're going to start by squirting and working. This is going to get another spritzer. All right. Contrast is down, brightness is, well, we'll just bring it up a little bit. Okay. And then down here, this is the tone control. And in the middle is a detent. Oh, that's so clever. So in the middle is normal tone, and then one way is plus treble and one way is plus bass, I suppose. That's pretty clever. And then, yeah, these G2 controls. I'm gonna get at this one first because the opening is there. And then I'm gonna squirt some in here. Easier said than done. I had flared the end so I could attach a longer straw to it. So let's do one at a time. This is the red one. We're gonna use this when we get our, oh, wow, that was stiff. I had to break that free. All right, that's good. Okay, well, I'm glad we did that because it was, I had turned them all down. Well, let's go to the blue one next. Let me put the straw on. Okay, our blue controller got the extra long straw. How about that? All right, that's a lot of juice that. I'll say this about these G2 controls. Don't change them because first of all, there's all kinds of, there's the high boost goes into this network of G2 controls. And they're all tied together by these special caps. And they are just, the wires are all double, triple wrapped with gobs of solder. These controls were not intended to ever come out, I don't think. I did change all three of these G2 pots on another chassis, and it was a nightmare, and I just don't recommend it. So clean it if you can. Okay, green G2 with the upward bent straw. Worky, 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 worky. We did the red. Because these really do need to be pretty clean in their operation because this sets your grayscale, or grayscale. So if they're intermittent, your grayscale is going to bounce around, and yeah, you don't want that. So we'll get these two screen controls, and then we're going to pretend that everything is fine until we get the first successful power up. I soldered on as carefully as I could some leads to these points where we're going to reattach some of these short wires in the cage. And I had some of these 2-watt resistors that are way out of spec, so these leads, these old 2-watt Allen Bradley resistors have these really super thick leads. Made it ideal to use that wire. So this point is our 870 boost. That's where it originates from. And we have this gray wire that goes into the chassis. And then we have this also, this point is used right here on this super short wire. So we need to, well, I thought with this lead, I could, once I get it in there, I get an idea of where it is, and I can make snip it off as needed and make a loop, and just solder to the loop instead of soldering to this. This pin, it's got a lot of solder on it now, but it did flow. That's one of the transformer leads in there. Attaching these thick leads at this point, when I still have access to it on the bench, I could do a quality job as opposed to trying to hack something together once it's in the cage. The front, so and the wire could be upright. Get higher and try to line head of another, but y'all short so that turn on and really tough to. And it's this year I typed that, so no sir, thought that together on set like one and fire. Those things worked out all right. I'm glad I did that. And this black wire is the focus voltage that goes to the CRT socket down here. this has been a big project to get this all back together. I've got the high voltage rectifier socket back in place, screwed back in place. These little retaining things have all broken off. Yep. Brand new water pump, brand new fuel pump. I'm using a foam brush because I don't have another brush to use, and this is actually not the right brush to use. But this is what I've got. I would even consider pouring this stuff on it because our goal here is just to get this loose particle stuff from being loose. And the TV repair shop has some construction materials in it these days. So it's such a beautiful day out today that I thought I would work out here. And while I had it upside down yesterday looking for working on that the underside with the urethane, I was able to look through the bottom and I saw this unfortunate thing, part of the convergence assembly. That's one of the coils. This one is the blue coil for the right side, and I do not have a replacement for it, so I'm going to pull that panel off, and I can only go so far with it because the wires are attached to the convergence assembly. But I'm going to gently see if it's got continuity. I think I can glue it back in place. I won't really be able to adjust it then, but you know, those are getting to be the unobtainable thing also. I looked through my Zenith parts, and I've got a few others, but not that one. And I can check the internet, but anyway, I'm going to pull the convergence panel out. Well, the good news is that yes, there's still continuity. There's the SAM says this should be a 16 ohms, this coil, and in fact it pretty much is, so that's good. It still works. This is just absolutely a case of the disintegrating plastic again. That's what this is. I don't want to mess with it too much, but that's what's happened. You can see it right there. Yep, the plastic is just disintegrated. So what can I do? If I put something non-conductive from through here into the core, I could probably epoxy it in place. I don't really have expectations of ever being able to adjust this. I really don't think so. These coils tend to get very hot when they run, and oftentimes those two on the right, as an example, probably aren't adjustable anymore either. So instead of destroying it by trying to adjust it, you just don't. So we'll see what happens to the convergence when we get this baby running. And some of these potentiometers, they are also seized up. So those I could probably work some stuff in there to try to loosen them up. These are the only induction coils in the convergence assembly, otherwise they're all potentiometers, wire wound pots. I'm looking for a piece of non-conductive material that's just a hair smaller in diameter than this. And I just happened to cruise by this little bin of junk on my workbench because I was trying to fix this pot, but the resistive element has given up, and I just thought, well, let me just look and see if this shaft is and it was like, oh my goodness, it's just about right. So it's more than just about right, it's absolutely perfect in diameter, and it fits right down into the core. Fits right down into the core, and there's even snugness there. So I'm going to use this. I'm going to take the brass piece off. I'm going to cut it off right about there. I used a Dremel tool to cut that off. I'm going to leave it like this. I didn't use any glue. I just pressed it in. This whole plastic core assembly is just disintegrated. So we'll put the chassis in. Yeah. Gently. All right, so these are the degaussing coil connectors, and we're not going to connect that. We don't care about that. It's actually bypassed. And this would be the convergence control wires. So we're going to put that one in. And we can let these just kind of hang over here. We are not going to put the Space Command chassis in. There's no reason for that. Not yet. And typically these are the speaker wires, and okay, I think it's this one right there. Well, getting this chassis in and out actually is not difficult at all. Zenith really had anticipated this now after the years of manufacturing it otherwise. So the plugs that come out of the chassis, they're all different sizes, meaning that they can only go into one particular spot, or the only exception to that, I have to go look at the pictures. I believe these are the two wires that go to the automatic fine-tuning switch, and I don't know where that is, and we're going to leave the degaussing coils. We bypassed that anyway before, and we're missing a horizontal output too. We got to put that in. So we'll move this beast back closer to the garage, or even in the garage, for our power up, but it's looking pretty good. Oh, we got to put those in there too, the damper and the regulator. So I did put the chassis screws back in, so it's secure. So when we get it over to the garage, we're going to tip it on its end, and the chassis will stay in its place for our fire up. Power up, not fire up. Ha 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 ha. Freudian thing. So these two wires, one of them goes to it's a green wire, and it goes to the AFT module back here, to that connector right there. This one either goes there. Yep, it's marked. It's there. Look, I marked it. Check it out. I marked it. Made a little black mark right there, next to that transistor. Run it into the shop. Put it outside. Turn it on. It's gonna work. Yep. Yep. So let's do this. We're plugged in. Yep. We are in current limiting mode. Yep. That is our chassis voltage. We're looking at right now, this is, I've tied in here to our 870 boost point. So we wouldn't expect to see much until there's some high voltage running. So we're seeing the oscillator start, I believe. Yeah, I don't know, that's pretty weird looking. Nine volts, 10 volts, that's going up. So let's assume the oscillator, the horizontal oscillator is running. We should see, yeah, glowage. Do I see I see minimum glowage in the horizontal output tube. 72 volts going into our chassis. 230, 40, 45 going up. So the only way this boost voltage could exist is by having the horizontal circuit running to a certain degree, because that's energy from boost plus, well, it's not even up to B plus though. Well, let's throw this burst to her. This is the only way we can figure this out. Hand on switch after that. Hand on switch. So this should start to increase dramatically. Yeah, I think we're going to be okay. That voltage should get to about 900 volts. Oh, look, we have high voltage. Sweet. We do. And I can't turn that down anymore. I don't want to burn that line in. Shoot. Boy, that is not, I can't control that. Why not? Let's turn it off. Well, that was interesting, and I don't really know what to think, but we had high voltage, yay! But the G2 controls and the gain controls, they're all down all the way, and I could not extinguish that line. Let's on this trip, let's see what the high voltage is. I have a feeling it's not quite right either. So one crisis at a time. We'll bring it up on our tester again. Yeah. Okay, so we're going to start in current limiting mode again. So it's the same process. Let's go for it. Hand on switch. Hand on switch. We should see this come up. Our boost is coming up, 650. Getting there. Yep, here's our high voltage coming up. Not nearly enough. Do we see it? Yeah, we sure do. It's only at like 15,000. Is it because no? What would happen if we go into normal mode? First of all, let's try our screen controls, up or down. These are our gain controls. Up and down do nothing. Blue, up and down. Red, up and down, does something. Turn these a certain amount. Okay. All right, our focus is so whacked. High voltage is gone again. What the hell just happened? Turning the screen, the G2's down all the way, brings it back up. Okay, I'm gonna go into normal mode, see what happens. Well, we have a raster. That's exactly what it's supposed to be, a full raster. All kinds of nightmare noise in it. I can hear the vertical transformer singing, and that that resistor is not starting on fire yet. So that's good. Oh, look what we have here. Hi, we have more high voltage. What can we do with this? Screen controls, up and down. They are like backwards. Well, we have a raster. Not exactly what we were looking for, because I don't understand what's going on. And we don't have fire coming out of this. And we have a full vertical raster. That's fantastic. You're just seeing the scanning bars from the phone camera. We have 765 volts of boost, so that maybe is low, but that resistor's not on fire. That means the transformer, the vertical output transformer, is fine. Not sure why we're low on the boost. Do I smell anything? No, nothing. It smells like a new TV set. All right, well, let's turn this off. Let's see let's quit while we're ahead. And why do we not really have any control over anything? Okay, we're coming up slowly. Let's go into bypass mode. Hand on kill switch. We should come up to a full raster, but we should not have a raster the way all the controls are turned down. But first things first. There we go. That is a raster. And we do not have full width. That's okay. And I'm going to switch it into setup mode. Yes, I am. Boy, that is bright. No, I'm not. I'm going to turn the focus and see if that makes any difference. I mean, I think so. Somewhere in there, maybe? If we go into just for a second. Man, that is bright. Shoot. We need to be able to extinguish this. We have 18,000 volts. That's not enough. Here's our high voltage adjustment. I don't even know if I'm turning the pot. But if I am, it's not doing anything. Yep. Yep. Boost 756. Huh. Yeah. All right. Well, let's see if our brightness controls do anything here. Oh gosh, no. Well, it makes it all go super out of focus. Brightness and contrast. All right, so that tells us that something's messed up. Picture peak control. All right, that brightness, turning the brightness up all the way is just probably overloading it. There's got to be a brightness range adjustment. So I got brightness and contrast down, but we should be able to, this is, see the horizontal? Oh, I should check the horizontal frequency before I mess with that. Vertical hold should be this one. Well, it's doing something, it's controlling it. I can hear it in the speakers. Well, it's a nice, well, yay, we have high voltage, yahoo! We don't think it's working right though, and we have to get this brightness control. figured out. And that I have no idea. That's not a good thing. Yeah, I don't know. Let me ponder this. I came out here this morning, wanted to fire this up and just see what's going on with it, read some voltages. And at first it came up with that strange over bright raster that we can't control. But look at this. Then suddenly the picture just corrected itself. Look at that. Just right. It's just right. Maybe even a little high. And I did look at this high voltage adjustment pot, but it is seized up. I can't turn it, so I can't do much about adjusting right now. But let's look at the screen. There's just a nice dim glow. I turn the contrast up. Let me show you. I'm in service mode now. And I'm gonna bring the green up. Look at that. This is exactly the way it's supposed to work. It just fixed itself. And I adjusted the focus. The focus control works fine. But one oddball thing I wanted to show you as I look behind. This is the red. Look at this. Bringing the red up actually brings up two different colors at the same time, green and red. So I don't understand that. But I can, you know, that was one of the, there may be tin whiskers in these G2 controls. That should be green. This, we turn blue up. I think these G2 controls were just contaminated. Bringing red up. It's still peculiar. The red still isn't just red. It's red and green together. And then green is fine. Green is green. So there's something that we got to figure out. Maybe it is that red G2 control. But as I bring up the red G2, I went back into normal mode. It's all messed up. So we don't have just a red raster. If I bring up the green G2, we have a decent green raster. And if I bring up the blue G2, yeah, totally blue. So maybe it's just a purity thing. Maybe it's purity, but this baby's working exactly right. This VTVM will actually read up to 1500 volts DC. So I have it in current protect mode, but let's go. Rev it up one more time. And we just wanted to look at what the high boost voltage is. I can hear the vertical running. Let's check on our high voltage. High voltage is coming up. Cathode current is A-OK. So our boost isn't quite 1200. That would be 1200 volts there. So, and we want to be up here, so it's a little bit low. Alright, so not to worry. I am wondering if possibly this horizontal output tube just isn't as strong as it should be, so that might be part of it. So we're gonna Now we know what it is. It's coming up a little bit. It's at 1200, so we were looking for 1280, so that's not really a problem at all. So I think we're good. The vital signs are all within tolerance or within reason, so we're gonna start looking at our signal path and see if we can get something on the screen. And if we can, we'll set it down. Well, I picked up some of these, I guess they call them bullet connectors. They come in a pack, male and female, if we can still say that. And I made up some of these extensions. And I'll show you where they go. They're going to go in the chassis between the solder cone points and the cathode leads to the CRT and the screen grid leads. Otherwise, there just isn't a very good way to get a meter probe in there, so I just thought I'd make these extensions. I've got 6, which is what we need. I've got the machine warming up, and you can see the 3 jumpers that are installed. We're going to get some voltage measurements. We should have high voltage. Yes, we do. And our picture is just where it should be. It's extinguished. So with our meter, these bottom 3 wires would be the cathode, and they should be about 300 volts each. 287. 284. 287. And then these are the screens. Should be about 150. Yep, 155. Uh-oh. 140. That would be the blue screen is low. And the green is also low. That's probably because they're turned down. Let me turn the green up. It's not super far away, so let's not concern ourselves with that yet. Let's look at our picture again. That's very promising, what we saw there. And as I turn the red screen back up, we get it almost looks like a purity error, and we're on its side, so we shouldn't get too wrapped up in this. Well, I set it back down, and I did want to take a look at the purity issue. And because either the problem is electrical down here in these G2 and gain controls, or it's up here and it's magnetic. And so if it's magnetic, we'll start by degaussing the picture tube. Our degaussing band around the picture tube itself has been bypassed, so we'll do it manually, which is a better bet anyway. You should do that often, or sometimes anyway. And these purity rings on this lateral magnet assembly just are stuck. So I happen to have I have one, a purity magnet assembly. So it has the blue lateral and the purity rings, and we'll change that out. So what first? I did manage to get this deflection yoke free. It really needed like 3 hands to do it. And I just wanted to, at first, take a peek at the purity by pulling the yoke back. And then I'll change this. And then I'll degauss it. Is that the right order to do these things? Why don't we just degauss it first? Why don't we just do that? Okay, let's do that. We're going to degauss this first. Okay, so we've got the set up and running. Just going to give it a degaussing. Who knows how long this thing is gone since it's been degaussed. All right. Okay. So what do we have here? Let's turn everything down except for the red. Well, what do you know about that? Holy moly, what a difference a day makes. All we did was degauss it, and that thing just came to life. What about the green? Look at the green. Look at the blue. Oh my goodness gracious. Let's go into service mode. And look at our line. Red line is red. It's perfect. Wow. Wow. Well, wow. Okay. Just a quick setup. Green and red and blue. All right. Wow. Degaussing is what it needed. Okay. I'm smelling something. Some funny business here. I wonder what that is. Yeah, I didn't really want to do that. Okay, I'm going to turn the green and the blue down so we have red. And I'm going to just get behind here and turn red up. Wow. And I'm going to try to slide this deflection yoke back. Like I said, it's... Look at our... Well, our purity is just about right there in the middle. And... there we go. I was able to just free up the rings. I don't think I'm going to mess with these. I'm not going to put this new purity assembly on for now. We answered our question. It's not, this deflection yoke is not sliding properly. It just sounds crunchy and not in a good way. Alright, I'm going to quit on this while we're ahead because it's pretty darn good. The picture tube just needed degaussing.